Welcome to the first episode of The Duchess
And the Doctor,
where we discuss everything that has to do with eventing and we answer your questions. Now, Matthias, you had a question.
Yes, absolutely. Eventing is a very tricky term. People also talk about stream processing and things like that. So the question is, what actually is eventing?
I love this question. When I talk about eventing with people, you have to understand that it's a mindset. I tell people all the time, when you're producing an event, it has to be in the past because it's something that happened to something, someone, Phil, right? And there have been many events that have happened to Phil.
Absolutely. He got extinct.
That's right. Extinction is an event. When you're looking at this type of a thing and you're thinking about a great example, one we use all the time is an order. It's boring, but it gets the job done. You don't want to say place order. You want to say an order was placed because then other people can consume that event. Maybe the shipping and fulfillment people can consume that event. Maybe the people that do invoices. Maybe the people that do your confirmation email, whatever service that is. Like, yes, my order went through. So that's really how I like to have people think about eventing. And then it goes into, okay, well, what events, in wherever I am, doesn't matter if you're in sanitation, you're in tech, you're in insurance, but your world is organized around things that matter to you. These events should be in simple language. There shouldn't be anything complicated about them. So if I'm in sanitation, maybe something is like a new house was added to my route. So route, my garbage pickup route. It's a very important situation. It's something I might architect events around. If I'm an online retail company, orders. I need to know when they're placed. I need to know what when things are added from them, subtracted, when they're returned, if they're shipped, right? All of these things. So that's kind of how, when I'm trying to explain eventing to people, or we're talking about, okay, well now I get eventing, but how do I do it in my world? That's what we talk about. You organize your events around the things that matter to you. What matters to you, Matthias?
Yeah, I think that's a very good description here. Because, if you come from the world of databases and SQL and everything, then people always say, well, everything is data.
Yeah.
What is also kind of true, an event is also data. But as you mentioned, it's a mindset. And that really sets it apart because you reason about it differently and you treat it differently and you set your systems up differently, how the data is processed. So if you talk about stream processing in general, it can be anything, right? And eventing is a very specific form of stream processing because usually you have a stream of events, what you call an event stream,
yes.
or it's also an overloaded term. But here we are very concrete about those things. Events are immutable, they're in the past.
Yes.
And so it's also data, obviously, but it's a very specific kind of data. And that's very important to understand. And it sets it apart from other stream processing things like streaming ETL or streaming analytics, materialized view maintenance, what is very hot at the moment as well in the streaming world.
Yeah.
But it's different, right?
It is. And I find the concept of immutability to be so comforting.
Yeah.
Yeah, just personally. Isn't it nice that it already happened, you can't change it, you can just deal with it. It's kind of like life. Eventing is life.
Absolutely. There's a saying, the world doesn't happen in batches. That is why we do stream processing. But the world also happens in events.
What about a batch of cookies?
Well, I would eat it.
Okay, excellent. So should we ask our first question now that we've explained what our show's about?
Yeah, sure, absolutely. And we just talked about events. And so the first question we got from our fan listener, Snooki, is what actually happens if I wait for an event, but it never arrives?
This is something that we see all the time, even though we know events happen quite often. And again, to use one of my examples, an order. So an order is placed, and then there's lines, these items that I've ordered. What happens if I know that I'm expecting 4 items on an order, but the event or the data to get the 4th item never comes? I never get that event. Or what if, and even this happens even more frequently, I have to interact with an external system, and so I'm waiting for that external system to send me an event back to do something, and I never get it. How do I know? What do I do?
Well, you don't just sit there and wait. Well, I guess you have to wait to some extent.
You do. But the number of times people have asked things like, hey, do you know how I can make Kafka streams pause for an hour? Or is it okay to throw a sleep in there? And I'm like, are you asking that because you're pretty sure after an hour everything you need to move forward is going to be there? And they're like, yes. That's not what we do, right?
No.
We use completion criteria. This is a pattern where we identify what we need to move forward to the next step. And then we can use, various types of joins. You can use predicates. There's all sorts of ways to translate completion criteria into code. But we never put a sleep in an event streaming program, ever. No, don't do that. It's just bad.
Yeah, it's very bad.
And so we need to know when an event doesn't come, right? And there are things that events drive, and I think this gets into something we were talking about. There are many systems and many, whether it's, library, whether it's a, streaming, like a processing framework like Flink, whatever it is, there are differences in each of those. And they handle this type of a situation. Your options are different a bit, right?
Yeah, absolutely.
So maybe we should talk just about, one that comes up frequently, Windows. And I have a good example of this, right? It's great. So there are certain types of things that we measure in events that don't happen consistently, or they happen much more frequently. Sleep apnea machines. This is my favorite example of this. You ever see the Darth Vader mask people wear? It's amazing. There's a great, by the way, episode, Abbott Elementary, shout out, one of my favorite shows, where somebody woke up, with the sleep apnea and it scared the pants off everybody. It was fantastic. But anyway, guess when sleep apnea machines collect data and send events?
I don't know. Periodically?
Yeah, but when? What do you have to be doing?
I don't know.
It's a sleep apnea machine, Matthias. It helps you sleep. You have to be sleeping. Oh. Spoiler alert. And so people tend to sleep. You might go to bed an hour or two differently or later or earlier than other people, but there's a concrete block of time where in a certain geographic region, most people are sleeping. There's an overlap of when people are awake. And so when they're awake, those sleep apnea machines are not sending events.
That makes sense.
So let's think about this. If I want to look at the span of data and try to analyze events coming from a sleep apnea machine, I probably want to, not look at those individually. I usually want to say, okay, what does the pattern look like in, say, 5 minutes? Which leads us to the next thing people get as soon as they do any sort of stateful streaming, as soon as they want to do anything good and yummy, they lead to windowing. See, it's a window. So, windowing. And that is a great way, I think, to break it down, because when we talk about windowing, in Kafka Streams, for example, which is an amazing library, it's a Java library that you can use. It's called Kafka Streams. So guess what system it works with? It's Kafka. It has windows. Right? Apache Flink has windows. SQL has windows. Everything has windows. So when we look at eventing, let's talk about K-streams. So I am with my Darth Vader mask, and I'm sleeping, right? And I am a sleep apnea company. I'm collecting all this data. All of a sudden, everybody's awake. I'm collecting this in 5-minute windows. As time ticks on, if everybody's awake and I'm not getting any incoming data, what does Kafka Streams do? Like, how does it know to send me a window?
Well, that's exactly the point where we now get. It says, well, if no window arrives, or no new event arrives anymore, then everything stops basically, because a stream is always assumed to be infinite and always flowing, right? Mm-hmm. And so in Kafka Streams, the window won't close. And then you get exactly the problem of the missing events that we started with. And so say you can play all kind of tricks in Kafka Streams to do that, but it's very, very annoying.
Yes. Well, and if everybody was like Sleeping Beauty, you wouldn't have a problem, right? Because she's continually sleeping.
That's true.
Yeah. So these are the types of scenarios where the absence of an event, it doesn't move the behavior forward, right?
Right.
Now, in Flink, for example, they have with idleness, which means that they can actually close windows. In Apache Flink, you can close a window without incoming data. And Kafka Streams, you can do that too, but you have to drop down into the processor API, which is belovedly called Pappy, one of my favorite things in the world, and do some tricks. So it's important to think about that, right? When you're designing application, not after you're already done. It's important to think about, what does my data what does this event stream look like?
And for windowing, I think it's quite straightforward, but there are also scenarios where it's much more complicated. You mentioned, for example, you're waiting for a fourth event. But then the question is, how do you even know it is 4 events?
That's completion criteria.
Yes,
correct.
Exactly.
Yes. So,
and now it gets more complicated, because for the windows, the completion criteria is the advance of time. Mm-hmm. So that's already given, but it doesn't have to be.
That's true. It doesn't have to be. And so I think when you're looking at those, you have to be able to plan for that. Whether you're using something like Flink, where you're using with idleness, or you're using something like Kafka Streams, and you say, hey, look, I want to make sure I drop down to the processor API, right? And I'm going to iterate over and make sure that my windows are progressing. Now, I will say this. The default behavior in K-streams is that every time an event comes in, it emits the entire window.
Yes.
So it isn't as if you're not going to get an update every time it comes in. And I think, we have a couple questions on that, maybe perhaps coming up later in the show, don't we? I don't want to suppress information.
That's a good one.
Thank you. However, we will be covering that more in detail, about those types of things. So Matthias, what's your favorite window? Why?
I would say it's a sliding window.
Bold choice.
Yes, it is. And the interesting part about sliding window is really that the term is overloaded. It's, I would say, misused in some systems. And not all systems have them. And so that is why it's very special.
Can you explain more to people like that? Because you and I talk quite often.
Yeah,
about
sure.
I also love sliding windows. Fantastic.
Yeah.
So
because
tell us more
they're so
about
smooth,
them.
they slide.
They slide.
Yeah, and that's exactly the point about the term, because sliding window really means it should be continuous. And so there's another type of window that in Kafka streams is called a hopping window. And in Flink, it's actually called a sliding window. That is also moving, but it's not continuously sliding. It's basically moving in fixed intervals. So in Kafka streams, we call it a hopping window. So it's discrete and not continuous. And that's a big difference. And the other point about the sliding window, and that is something that is very often misinterpreted, is that if you have a window that actually moves, then you have two things actually. So one is the size of the window, and the other one is actually the criteria when you evaluate the content of the window and you do a computation. And that's different for sliding windows because it has this very, very nice perk. When it slides along the timeline, you have your events here, it all evaluates when an event drops out of the window, not just when an event enters the window.
Right, and which is awesome because that's behavior based on no incoming events, right?
Yeah, exactly.
For that window specifically,
exactly.
Right?
And the point is really if you say you want to compute, let's say, the average of the last 5 minutes, then basically when an event drops out, well, your average just changes. And that is why you want to reevaluate it. And a lot of people don't see this, and actually some systems don't implement it. For example, if you take SQL has also what they call a sliding window. And so the term is this over clause when you type the query. But this type of window does not reevaluate when something drops out. So basically it's really, really sliding. It's skipping some stuff. It only basically moves forward when the next window comes in, as the next event comes in. So there's basically something drops out, reevaluation of the window is missing.
Yes.
And then the window can actually jump forward in time significantly, and you don't get basically the window draining out slowly and getting down to zero.
Correct. And I love windows. I think windows are probably one of the most confusing topics when we talk about eventing. How should I analyze this data? How do I want to look at it? What does it go about? And I think, I remember when we did sliding windows, and I remember thinking they were the coolest thing in the world because to me, they provide context.
Yes.
They're context about this slice, right? A window for a given key, right? I always like to think about wait time at a restaurant, right? Your current wait time is a function of recent up to a point events. You don't want to calculate wait time based on the senior citizen discount 4:30 dinner, where they get a table. If really you're trying to get a table at 7. There's that relative and that usefulness of information is based on time as it slides along.
Absolutely, and that's also a very important point where people are not sure when to use which window, because you have the hopping window and you have the sliding window, and they're to some extent kind of similar, but they're at the same time very, very different. Because the point is also how I look at it. If you have in general a time window, it could be a hopping window or a tumbling window, but it's just a special case of a hopping window where it's not overlapping. What you basically say, I start a window now and I look into the future, and then in the future the window is going to close. So semantically, I always think about how you set up the window. Mm-hmm. So you could say, I have a daily window, right?
Yeah.
And the interesting part about the daily window is that at 1 a.m., I can compute the current amount that I have today. The day is not finished yet, but I basically look into the future a little bit. And of course, at the end of the day, the window closes, but you get those intermediate results that are very, very useful.
Yes.
But now if you look into the sliding window is actually a look-back window. Mm-hmm. You always go into the past because you say, I want to have the 5-minute average from now, 5 minutes back. A sliding window looking to the future does semantically not really make sense. Mm-hmm. And that is also why this re-evaluation criteria when something drops out of the window is very important.
Yes.
If you look into the future, this criteria doesn't make sense.
No, it doesn't at all.
Exactly.
Yeah, that's why I love calling them look-back windows.
Yeah. Understanding this use case is very important because what we also have seen before we had sliding windows is that people said, well, I mimic a sliding window by using a hopping window with 1 millisecond.
Correct. And then how many windows do you end up with doing that?
Exactly. It's terrible because, again, this evaluation criteria now comes into play. Because if you say, I look into the future and I move my window 1 millisecond and the content did not really change, I'm not really interested to get the same result over and over again. Because if nothing comes in for a minute, well, you get like 60,000 of the same results.
Right.
It's wasteful in storage, it's wasteful in results, it's duplicated result, but the sliding window would just move along nicely and do what you want. So you can try to mimic it with a hopping window, but it's actually semantically completely different, even if it looks similar on the surface.
Isn't that often the case?
It is.
Yes, you have to dig deeper. This is our first chat, our first episode. We've introduced Phil. Matthias, you want to take us out?
Sure.
You're supposed to say something. That's what that means.
Oh, really?
Yeah, it's like you get to say goodbye last.
Oh.
It's an honor.
It's an honor. I didn't know that.
Yeah.
You see, I'm not good at filming.
Matthias, take us out.
Thank you so much for joining the first episode of D&D. Not about dragons, maybe about dinosaurs. And see you next time.